Testing audio. I heard it on 2 of them. Does Twitch have audio? Oh, I wasn't testing YouTube. Okay, it looks like I got audio on everything. Okay. And okay, great. Chat is up on everything. Sweet. Okay. So I'm gonna try some more Leak Code problems today. I think I want to try and explain things a little bit more deep. So we'll just jump into it and then I'll just try and draw it out. I haven't picked which one I want to do yet. Let's see. Strings of concatenations. I'm gonna guess what these things are gonna be. Dropping rainwater. First, missing positive. Sure, why not? Let's see what that is. Given an unsorted integer array, nums, return the smallest positive integer that is not present in nums. Smallest positive integer that is not present in nums. You must implement an algorithm that runs in O of n time and uses O of 1 auxiliary space. So nums 1, 2, 0. Okay, smallest positive integer. 0 doesn't matter. Like, since the -1 doesn't matter either. So it has non-negative. It has non-positive integers into it. Output is 2. Because you got 1, and then we're missing this. And for this one, it's 1. Okay, interesting. All right, so the idea here is we're looking for numbers 1. We want to check if all positive numbers exist. Like at some point where we will hit a number that doesn't exist, right? I don't know what the size, the length is, could be really large, the numbers, but presumably they're not giving us too crazy. But at some point, there's a number that doesn't exist, and we have to give that number. But to do that, oh man, I wonder, does this have like a dark mode? Because that's like, there we go. There we go, that's much better. Okay, sweet. So now, if assuming the numbers were sorted, this would be pretty easy, right? Because you just go like, you'd be like 1, 2, 3. Oh, there's something missing. 5, right? Like, as soon as we hit something that was missing, we'd just be like, oh, okay. We would just like go through the indexes. And even if there was like annoying numbers in the middle of this, it wouldn't be too bad, right? We'd just be like, we're looking for a 1, we found a 1. We're looking for a 2, we found a 2. We're looking for a 3, we found a 3. We're looking for a 4. Oh, we didn't. Like, this is an ignorable. We're looking for a 4 still. And when as soon as you hit like something bigger than 4, we could be like, okay, we're out, we're done. But the problem is that it's not sorted. And we can't sort because the best you can do, well, okay, well, I might take this back in a second, but generally speaking, sorting is n log n. That's usually the best you can do. There's an exception though, specifically with integers. So maybe we can exploit that, we'll see. But that makes things a lot harder, right? Because the naive approach to this would be, maybe I'll figure out how to draw this so that, what I'm trying to do is, I want to draw this out so people can understand, but I also feel like if you're coming into the stream midway, it's like, if I don't draw what I say, then it's kind of hard. But then also it's kind of boring if I'm just sitting here drawing the whole thing. Let's, we can split this, right? Or does it not? Let's do that. Okay. Right. Okay. Okay. Maybe that's better at least. At least then we can see everything. Hopefully that makes sense so far. We'd be expecting a 1, and then expecting a 2, and then expecting a 3, and then expecting a 4. And we'd be like, oh, we got this one. What's the hotkey for 5? We got this one. Got this one. We skip. And as soon as we hit this, then right in here. Anyways, we'd be like, okay, well, we didn't find a 4. Right? So this would be the easy way to do it. But it's not sorted. Now we'll put this here. If it was sorted. How do I? So, but it's not sorted. Great. What is it? So then the next sort of naive approach, well, you could sort, but then sort is O of n. So can't sort because of n log n. And we could go into what big O means and everything if people are not familiar with that. But this is just like it's like essentially how it scales. The more items you put in, how it actually slows down. And they want it to be in linear time basically. So for I only spend the more items in the list there are, the more it goes evenly. The more time it takes evenly. So we don't want to sort it. If we could sort it, then we just sort and do that. So now we can't. Let's change this back to white. All right, so instead, actually not sure which way I had. Sorry. New system learning it. Okay. doesn't look like that's as white as it was before. I'm not sure how to. I guess I could just make it. Oh, I'll let you pick the white. Well, why does it feel like, huh? That's weird. No, but that does look like it worked. Okay, weird. Okay. All right, so how are we gonna do this? 3, 5. I should just take the second example, looks pretty good. So we have 3, 4, -1, 1. And so if you were to apply the same algorithm up here, then like we would hit 3 and think we were done, but there's actually 1 at the end. So we need to reserve the um, decision if we have the numbers. So I'm thinking if you see, we can't do multiple passes. Just put that down as a thing that we can do. We can do multiple passes, but it's got to be if constant. So for example, we could find the like largest number. I don't know if that helps us. And the smallest number that also doesn't really help us because the gap's gonna we need to know if there's a gap in between there. We could do we could find max/min/sum first. So I'm just like putting down ideas that I'm having while I think about how we could do this. Sum feels promising because it's almost like a checksum, right? Like if we add all the numbers within a range, once we know like max and min value ranges that we're looking for, it should be. But we're at least going to ignore anything that's 0 below. And then we're just looking for positive integers. We know we start at 1. And then if we were to go through the whole list, we'll get a max. We should be able to know what the mathematically we should be somewhere to know what the sum of that would be. And we can find we will know the difference, right, between where we're at and what's missing. The only problem is that we don't, there could be multiple gaps. So I'm just gonna show that work, right? How do I do that? Oh. For example, in that list, we know that like max is 4. Sum is, if you ignore non-pos, would be 5, 8. Expected sum would be 1 plus 2 is 3, 6, 10. 10 minus 8, missing 2. However, could be missing more than 1. Right, so that almost helps us, but not quite. Um, trying to think if we can break. I'm trying to see if this helps us at all, because like we have, it feels useful to know the values that are missing, right? Because uh, like the missing amount is still going to be of different positive. What I mean by that is like, so if we are more difficult, yeah, so like for example, this one, right? So we take this set and we do light. I did not want to do it. Well, um, like here, 8. R B. What? I don't want to do that. Sorry, learning this program. Don't want to do in here. I'll do it afterwards. And then, okay. In this one, the max would be 12. The sum would be what is it? 20, 23. 23 plus 9 is 32. Right? So yeah, okay. Plus another 8 is 40 plus 7 is 6. So the unexpected would be 8, 9. We're missing 10, so it'd be 57. And then we're missing 6, be 63. We're missing a 5. We're missing a 4, 3, 2, and oh. So expected. And so then the diff is 331. So then 31. I don't know if this really helps. I'm just like going through all my thinking process. Oh, hey, Tony. Still looking for work. I took a little bit of a break from hunting. I'm working on my finances and trying to get a better idea of exactly how much I need to ask for money wise. And then I'm probably just gonna lower my expectations, try and search for something a little bit more reasonable. Thanks for joining the stream again. If you got any questions, let me know. I'm working through this leak code problem, and I do not have a solution yet. Just writing out my ideas. It's like 30. So this is made up of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 10, right? I'm not sure if that really helps me very much. Yeah, it's just like there's so many possibilities. And I don't think I would be able to know that these are the numbers that make up that. I feel like there's like a lot of combinations of numbers that might have been in these numbers. So I'm not sure how the sum or the max helps me here. It also doesn't want us to create any extra memory, right? I could theoretically create um, create a map. Like a well, yeah, I could theoretically create a hash map, put them all. It'd be I think it would it be O N to fill a hash map? I think it might. Um, let's just assume it, even if it was, it still would end up being more than O of one memory. Um, then I could pull them out and just like run through. Is one in the list? Is two in the list? Is three in the list? I'm gonna put this off to the side for just a second while I think, because I think I remember there is a sorting algorithm that works O of n if uh if it's integers. And I don't remember what that is. Um, it says it's O of one. I don't know, it's O of one, so I can't even like make a secondary list. I was thinking maybe I could allocate another vector and then just move them in their place where they should belong. So I've got like, should I like make sure that this is clear that this is going to be a separate thing? Running out of space right quick. So my idea was do 1, 2, like, well, let's do the simple 3, 4, -1, 1. And then, so my idea was to create a list. We can't do this though. And then basically you would take each number and you would put it where it belongs. Um, 6, right? 5. So you go, oh, 3 has to go, that's not the right number. 5. There. 3 would have to go here. I guess you'd have to first do the max to know how many you need. That's the problem. We'd go, try this again. If we got this input, we'd first do a pass to figure out the max. 4, right? And so then we would know we need, then we would know we need 4 underscores. Which is a faster way to switch between these. I wonder if I should just copy them into it. We could make an array of 4. Right? And we know we'd like what we need is 1, 2, 3, 4, right? And then we would start, we'd go through this initial list and we'd put them in their place. So put that there. We'd put the 4 over here. We'd skip the -1. We put the 1 over here. And then we would just look for the first missing value because we'd have like, oh, there's a value here. There's not a value here. Hope this is clear. What's going on? If you're still there, Tony, tell me if it's not clear. So we just find the first missing one, and then we call it a day. But we're not allowed to allocate more space. So I wonder if we could. So now what I'm thinking is we're going to do everything in place, but we're still essentially attempting to sort. And I'm trying to think. Oh, I don't know if we're guaranteed that the numbers don't repeat. If we assume that they don't give us two of the same number, this might work. The idea that I'm having right now. The idea is first, how about sort in place? So we're gonna do so we take the first number. Although the problem is we still don't necessarily have as many. Okay, in this particular case, it works well because we have 4 items and we have 4 things. So I'll just show it since it was an idea, but the problem is that we're not guaranteed that the input array is the size that we need. But the idea would be we take 3 and we go, oh, 3 needs to go to the third location. And so we would change this to 3 and hold on to the negative. Of course, then what do we do with the negative? I'm not. That's a problem. Let's say then we just move forward, I guess, if we hit a blank. This is clearly not going to work. But then we go to the 1, and we go 1 goes into the first place. So we go 1. Yeah, see, it doesn't work because then we go back to 1, and then we'd be like, oh, what was no? That's 3, and then we left it behind. I guess we could. I guess we could swap. Yeah, what if we instead swapped? I feel like we're getting into like sorting where we're gonna end up. If we swapped it instead. Right? Um, if we just do this, I'm trying to think what the rule is. Because like, do I stay where I am like after I swap? Uh, or do I move forward? And it seems like, well, I've got this -1. I'm not sure what to do with the -1. So I have to move forward or something, which would then get me to 4. Um, I guess let's just this. We would then swap the 4 and the 1, right? And then, sorry, that would give us 1 is here, 4 is there. And then we'd have to swap the 1. We have to stay where we are and swap the 1s. And I guess if we were smart and we like counted, if we're keeping track of like how many swaps happen, we know that we looked at every single value at that point. Let's pick -1, 1, 4. Okay. And then we'd have to do one more pass just to find the first number. We do what we had over here. We'd have our sorted array. So this won't work if there is duplicates, right? Just gonna call that out. won't work if oops. Does it tell us, given an unsorted integer array, return the smallest positive that's not present in them? Similar to the ones, there's space. Don't give us an example where there are duplicates. Can we survive duplicates? I wonder if we already have to deal with this case of the -1. If the -1, if we're on a number that's invalid, we have to move forward. I wonder if we can do the same thing if the number already, like if the location we're at matches the value that we're at, right? So if we were sitting on 1 and its value is 1, we're going to end up swapping with ourselves. So there's no point. We can move forward. It's already where it belongs. Okay, I'm not convinced that this is holistic. It's going to actually solve every problem, but I don't know if I need to worry about dupes or not. They don't tell me. Is there some test cases here, or is it just the test cases are those ones? Okay, I don't know if that works or not. But I also think if I move forward when I'm already in the right spot, that it will be okay. If I really want to prove this out to myself, I probably have to come up with a lot of test cases for duplicate values. But I feel good enough. I'm gonna give it a shot. Okay. So now let's type out the algorithm. So the algorithm is going to be like, oh, we also didn't, oh wait, there's one more problem, which is that, no, actually, okay, we don't have the problem of the size being wrong, because we're really just, this is just like a special kind of sort. So at a high level, it's going to be sort in O of 1, or O of n, and then find first invalid, or first missing number. It's going to be the two major steps, and then for the sort, it's going to be swap cursor with, or can we say like cursor start at index 0, swap cursor with where number should be, if cursor is on invalid or correctly positioned, move cursor. Right, so we start at the beginning, we swap what we're looking at with where it should go, we swap those two numbers. And then when the number is either invalid, meaning it's not a positive number, or if the number is already in the right spot. So if this was a 1, we'd also do this. We move the cursor forward, and then we attempt to do the next thing. I'm worried if this violates the O of. Do I get to count that? When I move the cursor forward, do I count that as an action? I think I might. Like we're basically saying we already did it and we move forward. It's very important that I'm only doing a single operation once for each possible character. So when we do this swap, we're pulling in a new item. We've done this item and it's handled. And then when we pull in this new item, we're going to evaluate it. And the result of that is either going to be another swap or it's going to be moving forward. But at which point then we're done with that one. We did do our operation on it. I suppose we could end up hitting a number that we'd already done and we'll do it a second time, but I think at worst it's going to be O of 2n, which is still O of n. I think we're okay. I think we're okay. If this was an interview, I feel like the interviewer would be able to give me some feedback here. And I wouldn't need to think through if I'm adhering to the policies or not. Okay. So we need a let cursor equal 0. And then we're not going to even necessarily use this number, I don't think, but this is to keep us honest that we only did an operation one loop per number. I less than swap length plus. And we're gonna need a swapper. Let's initialize it once. I don't know if this will matter a lot much, but it's just nice to initialize it once. If you want to be really nice, then we could also either cache this or set the I to this and go backwards. Depending how crazy we are. Excuse me. And then I'm not even sure in JavaScript this is the most efficient way to loop, but now I'm just caching the length at the beginning. Slight performance improvement. Okay, so first we have to do so this is technically else. Right? So if the nums at cursor is less than or equal to 0, or nums cursor equals cursor plus 1, right? We were indexed 0, but we want 1 in the first location. Then we're going to move the cursor forward. We are done with that number. Cursor plus. Otherwise, swap. Otherwise, we're going to say nums at the cursor. We're going to go swap equals nums cursor. Nums cursor equals nums. Wait. Yeah. At swap plus 1. So if this value equals 4, we want to put it in the, actually it's -1. If it's 4, we want to put it in the third position. Is this check right then? If the value here equals cursor plus 1, yeah. Because if the value is 1 and the cursor is at 0, that's in the right spot. So cursor plus 1 will get us to this. I suppose if we wanted to keep it a little bit closer, maybe the value indexed there, like this. So pulling this index out. I don't know, this reads better for me. Okay. So that's going to equal that one, and nums swap minus 1 equals the swap. Hopefully that makes sense. We're doing this like turnaround of these two things. Okay. Can we? I'm kind of new to leak code. Yeah, I want to just like see if this is even like close to right yet. Nums. Can I just run this? See what happens? Function whose declaration type is undefined void must return a value. Okay. And 0. Okay. Oh, we got standard up. So we don't care about the 0, and it's still sorted. And that looks sorted. Yay. That does not look happy. Okay, what happened? Okay. See, this is the problem. Yeah. The size of the array is not necessarily big enough to hold all the values. I can't allocate more space. Yeah, then this is pretty challenging because I'm pretty sure the only O and sort uh requires that you have O then space. Okay, so this did not work. Doesn't work because requires n sized array. Nice about like a proper. Oh, there is a red. Not super red, but okay. Well, shoot. Okay. What else can we do? We can't clamp it, I don't think, because might have to give up on sorting altogether. Um, so two things I'm bouncing back and forth in my head are, is there a different way we can sort it? Or is there a different way? Can we do this without a sort? Um, and it feels like sorting's going to be impossible. I wonder if just the length tells us anything, because like I mean we could do a pass to find the maximum integer. Um, but that doesn't really help us much. You can always just put a 1 somewhere, and it like screws up sigma mins. I can't store any extra info, and I can't loop more than one. Taking all my tools away from me. Like if I try, like, my gut is just go search for 1 and then go search for 2 and then go search for 3, but that's definitely not going to be open. I wonder if we can do a modification of this where we what if we only worry about numbers that are smaller than cursor? I'm not sure how I explain that, but basically the idea being that we're gonna go on a trip to go find 1. Or rather, we're gonna go on a trip to find any value that's below where my cursor is. Okay, I'll make this smaller and move it up. I don't even know if this is getting readable. Okay. All right, so the new idea is this. What's our input? Actually, let's just copy this. We are Can I go? I wonder if I can evaluate items that I swap in. Because at worst that's going to just be 2n, I think. Sorry, I'm thinking through my solution while I'm trying to figure out. But the idea would be you start at the beginning. And anything that could go here, actually I have to keep two values because it's basically what we found so far. Sorry, it's getting kind of hard to fit. It's what we found so far. Playing with the but one cursor is keeping track of what we found, and one cursor is keeping track of where we're evaluating. Found the cursor and like checking cursor. When we go to check something, we can only swap it if it's behind us. Because we might trying to swap it forward might result us going on the end of the array. If we hit the end of the array, then what we found so far is the smallest number. And I think we can just ignore values that are negative. So for this, what that would look like is we'd go 3, 4, 3, 4, 1, and it would go, okay. Can I, like, I'm totally with keeping this on the screen so people can see it versus trying to show this. It's over here. Let's do another orange arrow to going up here. All right. We're gonna still have, so we're gonna look at the first one. It's not a number that's equal to or less than where we're checking. So right now we're at 1 essentially, right? So we'll move. It's probably going to be a pretty boring example because we're going to go through the whole thing. So we'll move the cursor, the checking cursor will move forward, but not the found cursor, right? And then again, 4 is not there, so we'll move it. It was like 3 times or something. This one will move to the next one. It's still not. Then we'll move to the next one. This one is in the right spot, so we will swap and move forward. This will become 1. And this will become 3. And we'll move that. Hopefully that's obvious. This 1 is going here. And this 3 is going here. And then we're going to move to the end of the array and we'll be like, oh, well, our found cursor is sitting at 2. So the value is 2, which is the right answer. Now, if it had been a number that we do know, then like if we pulled in, actually we still have to do that, right? Because we would pull in 3 and we're going to go, oh, well, 3 goes where it belongs. Sorry, we do have one more step here. Like 3 is going to have to swap too. Oh, no, we can't swap because 3 is still smaller than 2. We're looking for 2. So we can't swap in 3. So then this is not going to work either, right? Because imagine if we'd had a 2 at the end of this. What if there was a comma 2? Right, we'll have to go back and reevaluate, which then is going to bring us over the so put the 2 in, and then we'll try and swap the 4. In this case, it might work because the 4 is something, but if the 4 had not been, we'll never reevaluate this 3 to get it into the right spot. It's close. It feels like reasonable. Oh, hey, I got a chat on Twitch. Twitch chat. Hey, 5 alive. Oh, is that a reference to Short Circuit? I love that show. Um, man, my chats are all messed up. There we go. If you got any questions, fine, let me know. Trying to like work through this hard level leak code problem, and it is kicking me. Okay. I'm trying to see if this approach is salvageable because well, let me just mark out the problem too, which is we never go back and three. We'll never put 3 in the right spot. Even if we swap the 2 and the 4, we'll never go back and find that 3 is there, and we will incorrectly think that the answer, if there was a 2 at the end of this, the answer would be 5, but we'd never figure that out. We would think that 3 was missing. And I can't just keep moving this cursor forward and hoping that we'll find the 3 because they might be in the wrong order. Like imagine if 4 was like 100 or something. We can't move past that. This feels like this is a dead end too. I guess the thing is if a number is bigger than, actually, I wonder if we can go back to this. If a number is bigger than the size of the array, well, if it weren't for the fact that we had these annoying like invalid numbers in it, if we didn't think about that, this would actually work because any number that's greater than the size of the array can't possibly, what are we missing? How do I explain this? I'm gonna go back here. We any number over array length is ignored. It's not quite array length though, because we do have to like, well, isn't it though? Because even if there's negative ones, right, if we've got 4 items, 1, 2, 3, 4. If there's a 5 somewhere in here, then we can't possibly, we have to be missing a number in here. If there was a 5, we'd either be missing the 1, the 2, the 3, or the 4. Otherwise, it wouldn't fit. So anything over length. Actually, maybe I gave up on this one too early. Let's actually bring back our failed attempt. And let's just add one more condition. Which is that, so if less than 0, or it's greater than or equal to, it's 4, not greater, that has to be greater than, because there's 4 spots, 4 is okay. Nums, that one. Then we're gonna move the cursor forward. Well, let's try this. So this one's sorted. It was really this one. So this one's still sorted, and I'm pretty sure we would still find that 1 is the first thing it's missing. Okay, let's finish this one up and then let's see. So we've got it now properly sorted. Now the last thing is to find the first missing digit. And we still have to skip over invalid items. So this is loop 1, loop 2. I'm gonna do the same thing again. This time oh, I don't know. Finding or something maybe? We're gonna find 1. Actually, I think we can assume, let's see, we'll just do finding 1, and then we'll do cursor. We're gonna set cursor back to the beginning. And we're gonna, for the length of the array, keep checking until we, all right, so we have a similar check to this one, but it's the opposite. If it's invalid, it's less than this or greater than that. It's one of the ones that we're not worrying about. Let me make this a little small. If it's one of the ones we don't care about, then just go cursor. So what is just gonna keep moving the cursor forward? I think we might, but let's just figure that out afterwards. Okay. So if it's one of those we don't care about, move forward. Otherwise, if what we're finding equals cursor, the value that there matches the value that we have, then we can also go forward. But otherwise, if it's not, then I think we can just break. And what we're finding is the first missing one. Let's see if that works. I just messed up it. Okay, why did this fail? If cursors, if the value at cursor is less than 0, which it isn't, or if the value at cursor is greater than the length, which it isn't, then increase the cursor. So it wouldn't have done that one. If finding 1 equals nums at cursor, then increase the cursor. Oh, and we found it, so finding has to go up. Finding plus. There we go. 3, 2, 1. Okay. Now we submit it and we see if one of the bigger test cases has something we didn't know about. Oh, sure enough. Oh, they show us it, so we can know what's going on. That's nice. So we got a really big number. Standard out was 3, 2, 3. This 15 ended up not getting evaluated. And so then, yeah, 4 was, we were looking for we're looking for the one we didn't feel it's not where it's supposed to be. So how did that work? Because we should have went 1,000 and skipped to the 3, and then 3 we swapped into its right location. 0, 1, or 1, 2, 3, and then that would have put 4,000 here, and 3 we would have skipped again, or we would have said, oh yeah, well 4,000's in. Well, what should have happened is 4,000 should have been. I see what's happening. Okay. So we do end up sometimes evaluating a value twice. I wonder if we're swapping. Okay, so first let me just show what happened. What happened is we had 1,000, 10,000, 100,000, some really big number, 3, 4,000, 2, 15, 1, right? So we started here and we went, okay, well, that's not a number we care about, so let's move the cursor forward. And we went, oh, this is a number we care about. I'm just going to move this all down. So let's swap it. And we swapped it with the third position, 0 or 1, 2, 3. Should be this one, right? We swapped those two. And then we're going, okay, well, 4,000 isn't a thing we care about. And then we go, 3 is in the right position, so we don't need to worry about it. Now we go to 2. And we swap with the 2. But the problem is that we've already evaluated this 4,000. And we're keeping track, like we're making sure that we only evaluate each thing one time, so that it's guaranteed O of n. But the problem is we're now looking at 4,000 again, and we've already evaluated 4,000. Now what I'm wondering is, can we assume that anything behind us, if he gets pulled in, was already evaluated? I feel like that's true because we're just staying where we're at and we're like swapping the things either behind us or in front of us. When it's from in front of us, we need to reevaluate it because it's something we haven't necessarily looked at. This is all still assuming that we don't have duplicate values. They might throw a duplicate value in here, and then I don't know what we're going to do. But assuming that every integer is only shown up once, then I'm only going to be pulling in values I haven't evaluated yet from there. Pretty sure that's true. But behind me is things I've already evaluated, so I can't count that. So I think what we do is we do the swap, but if we're swapping with something behind us, if the nums at the cursor, if let's do the swap, but if swap is less than or equal to, it'll be equal to, right? It's less than, because it swaps -1. If it's the value we're swapping, in this case, 2 is less than cursor. We want to move cursor forward. But is that the right? I'm just making sure I'm not off by 1. at most, I could be swapping with 0, 3, 1, 2, 3. I'm trying to swap 3. Cursor's pointing at 0, 1, 2, 3. But I'm doing swap -1, so 2, 0, 1, 2. So that, yeah, I think that's right. If the index that I'm swapping with is less than where we're at, we need to increase it because we're swapping back into something we've already evaluated. And we will have already put that in checkbox. It should be something that's not odd. Okay, first let's just check our simple test cases work, and then we'll try the big ones again. Ah, told you. Duplicates. Okay, well, great. Okay. I don't know how any of this is going to make sense to anybody coming into the stream late. Gonna do it. Another orange arrow down here. And we're gonna say this is we do need to worry about dupes. Okay. I suppose, can we also overcome this just by one more check, which is that if the value, so let's think about, let's just for a second, let's do something similar to this, but we'll just for the thing. So really just play out how this didn't work, why the dupes didn't. I was expecting dupes to fail, but let's just really quick make sure we like understand in our heads why exactly the dupes don't work. Because what's going to happen with our algorithm is we should swap 3 into place. 0 or 3 go 1, 2, 3. We swap 3 and 3. Okay, it's exactly that, right? This fails very fast. We swap 3 and 3, but now 3 is in the same place. And then we swap 3 and 3. And when we swap, yeah, I'm actually confused. Well, why does this cause an input loop? Right? Because we don't move the cursor forward, generally. Doesn't this cause an infinite loop? We 0, 1. Oh, no. 1, 2, 3. No, 1, 2, 3. We swap them. Because the 3 minus 2 is not less than the cursor is at 1. We don't increase the cursor. We come back around. 3 should get us swapped again. One second, let me. Oops, so that's gonna be too slow. This might be really slow. See if we can get better output for these. 3, 3. Oh, it doesn't infinite loop because we got this nice card, but it is basically infinite looping. Okay, good. Say, won't you just stay here forever? It does stay here forever. Yeah, I'm wondering if just like if the swap values are the same, then we can also just move before we don't do the swap and we move the cursor forward. It still has to be evaluated, so we still get to do it. It's just like I guess we can do the swap. It's just like at or if the swap value really is equals, right? Like if the value that the location we swapped is really just change this to equal. No, I don't think so because like, this is saying if the this was checking to see that like we're pulling in a value that we'd already evaluated. The second check is that if the if the value we need to swap with is already filled with the correct number, then we don't. I do wonder, like, okay, so now the issue is I'm now worried about evaluating uh reaching the end of the array and going off the edge of the array. Because I need to decide to skip this thing. And it's like I'm gonna skip the 3 because there already is a 3 there. Move the cursor forward. And then I get here. Well, maybe it's fine. Well, it's fine. It'll evaluate this one and this one. All right, so let me please out quick. There's one more, which is maybe we should also like call this if not positive. If half end of array. What was this one? If in the right spot already. If actually there's a similar check, which is that um I'll come back to this. I forget what this is. I think it's just at the same position. But I wonder if this check will do, which is that if the place that we would swap with if num the value we're doing it So 3 minus 1. If that value equals the value that we're currently at, equals the value that we're going to swap with, then we also just move. First of all, let's just check to see if that's right, and I can add in the comments. Okay, that fixed that problem. So if value is current close, or if value at desired location is already built. I'm getting messy, sorry. All right. Now, how do we fail? We expected 4 and we got 2. There's definitely a 2 in there. Oh wait, that's a 22. Oh. This will be fun when I'll type out. Geez, this is gonna be super entertaining. Okay, we may have to like resort to a different method of demonstrating this. This is too much. Whee! Where is the 2 in here? We expect, that means there's a 2 and a 3 in here somewhere. Yeah, there's the 2. And I don't see the 3. Okay, time to switch to something else. It's gonna be hard with this. Oh, there's the 3. Yeah. Okay. Let's just search how many. 52 matches, which means there are 53 elements. We don't have a comma at the end. Great. All right, well, this could be a long time of me trying to show every possible swap that happens. Can we think of a simpler example? That might demonstrate the same problem. We skip all over these. We're gonna do this. We're gonna do all of these are gonna get evaluated. Actually, is there anything over 53? I don't think so. I think everything is nicely in range. I don't know how we're gonna figure out where 43 is. There's also duplicate. Okay, so this doesn't come into play because there's, I mean, this does. We skip over all the negatives, but then this one doesn't because there's nothing over 53. We do have now a case where we've got less numbers than spots, but I think that's already this case. It's getting pretty late. I might have to give up for today. Because this is gonna trying to figure out what the edge case is here that I'm missing. Looks fun. Well, fun in a sarcastic way. Just trying to think if I can clairvoyance the answer here. There are lots of duplicate 50s in here. I see that. But we should like swap something in and then stay here. And then, depending on what it is, move forward. Actually, real quick, this is 161 of this. I do just want to double check that I didn't do this one wrong, because this should be go back to our earlier fail case and should be a smaller number. We didn't, otherwise it means we didn't pass. So 161. If the number is less than 161, I know this is a new fail case. If it's okay, good. All right, okay, good. This is not. This is fixing this 129 one. Okay. What does this say? What does this use test case do? Oh, that's nice. Oh, I didn't know you could do that. So now if I hit just normal run, I won't have to resubmit. Oh, that's very nice. So then theoretically we also could console log out these. We wouldn't have to wait for the whole thing. Unfortunately, that doesn't. Because of the standard out, it's like showing it in the final sorted version. Let me just join with comma. So I'm like forcing it to convert to a string. Wait, it's still not. Am I console logging in the wrong spot? Where am I? Wait, what? It looks like it's printing the same array in the final sorted version. Oh, 1 second. Sorry about that. Just didn't want to like stream the public announcement. Okay. I'm very confused why this is printing the same value each time. If I console log, when I join the array, it should be creating a new string each time. I should be getting different values as we go through the list. But it does not seem like that is what's happening. What? Like normally, like I know that like sometimes I don't know how they're actually doing this. It would, but like in normal Chrome debugger, if you just console log out the array, it's a pointer to the array. If I'm modifying the array in place, then it seems expected that I might end up getting the final result of the array, which is this one, printed a bunch of times. But in this case, I'm turning it into a string at this moment, which should create a new string each time, and I should get a different output. But that's not what's happening. I'm getting the same string. That doesn't make a lot of sense to me. So then, what if I create a new array with all the same values? Nope, same issue. This one looks right. Oh, is it just that it's happening after? No, this one's doing the right thing. Okay, okay. So then it's just because I'm not drawing it at the beginning, I'm drawing it at the end. And so it's doing that first swap with 40. And then probably exhibiting the issue that we're having. Okay, so that's like a promising. So you don't even know if I need that. Let's move this to the beginning then, because and maybe we should like also print out what we're print out the cursor and the value cursor. Let's try that. Okay. Okay. So we're at 0, we have got 43. So apparently swap that in to the right spot, somewhere in where the 1 was. One of these ones. Got the 43, this one did. Okay. And now we're going to stay where we are and evaluate. And what we do is we decide to move forward the cursor, and now we're looking at 20. And then we swap in the -4 with 20. And so that -4 was here, but now we've got the 20. That's good. And then we're going to skip over the 20, the -4 because it's invalid. Actually, this is so far so good. What's the final output? 1, 3. So this 2 did not get put in the right spot. Remember how I said I was worried that we might, that this check my guess is that we're not actually, like, we're basically stopping early. That's my guess. Somewhere in here, we're getting to the end, which means that we're considering, we're checking a value twice. This probably has to do with this thing, right? I feel like just in this case, I could give us one more chance, but I don't understand why. So I feel kind of dirty doing that. But I'm guessing that's what's happening is somewhere in there when we do the dupes. Where's our first dupe? 439, 8, 17, 3, 8. Okay, let's just think about the dupes again real quick. So in this case, we're going to examine, we're examining this 3, and we're going to skip it. Because the number at cursor, which is at 0, right, equals the number at where we'd want to put it, which is 3 minus just 2. They're already equal. So don't do the swap, move the cursor forward. Then we should swap 1 and 3. Right? But because that's behind us, is it behind us? Is this where we swap the value at the swap 1 minus 1, 0 is less than 1 where we currently are. So it'll do the swap, but then it will move the cursor forward. Okay. Let's do a swap with this and this. Then this thing should hit, right? If the value of the cursor 3 is equal to the cursor 0, 1, 2, so it's the same value, then that should also move forward. But what if this had been a 3? Then it feels like we would have also checked to see if the values were the same. We would have not worried about it, and we would have moved forward. So it feels like something is probably causing us to end early. So the only time we don't move the cursor forward is when we swapped in a number that was further down the line. Otherwise, we keep moving the cursor forward. So the only thing that would keep us from getting the end are the big Okay, I think I see what's going on. So we don't always move the cursor forward, but we do make sure we only do this. And if cursor, that means we're, by definition, every time we swap in something that's larger, we're not going to end up making it to the end. So let's try this again. Let's go down here. Let's just do like completely like oppositely. 4, 3, 2. Oh, no, let's not do that because that will 3, 2, 1. Like that. So we're gonna start like this, and then we're gonna swap in the 3 with the 4. right? But in this case, that's okay because we're swapping it with something and we never need to get there. We never need to get the end now because we swapped with the last item. So this is not a good test case. If we do 3, 2, 1. 2 over here and 4 over here. Well, the 2 is like that. We need to make sure that we get to this 2 and attempt to do it. The 3 is going to swap with the 1. But we're not going to move the cursor forward. Yeah, this is going to fail, right? Because we're not going to move the cursor forward. And then 1's in the right spot, so we'll move forward. That one's in the right spot, so we'll move forward. In this case, the 4 is fine because it's in the right spot, but like, let's say this had been -1. Let's go to test case. 3. Can I add another test case in here? Can I create my own test cases? Contribute a test case? I gotta log in. There you go, re-log in to do it. Hey, you can add another one. Here you go. Test case 5. Okay, let's try this. 3, -1, 2, not 2, 1, 4, 2. Okay, let's try that. This is all right. Huh? What did I do wrong? Oh, this is not a comp. Okay. What's wrong with my test case? Oh, are they all commas now? Yeah. See, this one also failed. And for the same issue, which is it doesn't get to the end. So my inclination is to be like, we'll stay where we are because we have to evaluate the one we just swapped in. And don't move the cursor forward. I'm wondering if that's still O of N. It feels like yes, because there's a limit to how much I feel like it's gonna only be able to do. If you pull in another number and you're able to do something with it, swap it forward. At most, you can only do that if you did that for all the values in front of you. It's just going to be O of N. And then you'd be done. The rest of the loop would just go through everything. You'd never be able to do it more than once. And so it's still at worst going to be O of 2. So I think if we just say else, normally we I plus minus minus, so I plus plus just to like keep us in the right position. We'll see if that fixes it. It does. Okay, sweet. So hopefully that's clear what's happening. Is that before, whenever we swapped in a value from in front of us to here, we stayed where we are because it's a new value we haven't evaluated. But then the problem is that means we were never getting to the end. We were this like this thing that was keeping us truthful to our O of N was not allowing us to get to the end. in order for us to go to the end, we have to move the cursor forward the same number of times as n. So we just make sure we don't move this forward. And then through complicated logic, I'm proving to myself that I still think this is O of n, because at worst it'll be 2n. If anybody wanted to go into deeper onto why that is, but for now, let's see if this passes. No! Man, we're so close from the last things. Output limit exceeded. Well, is that just because I'm console logging? Let's just get rid of our console logs. Oh, I can't get it. Alright. Could be just console logs. We still could maybe be in the clear. Yeah! Did it. Accepted. And we're in the runtime 98 percentile. That's very nice. And we're in the 86 percentile for memory. If I had more time, maybe we could try and do that. Okay, so this works. Sweet. Do we put a circle around the one that actually the algorithm actually worked? So it was essentially this one. It ended up being the right thing. And you can see all the logic that we went through, and we gave up on this and went down another path, and then came back to it. And that is the truth of software development. Everything else, something works. Sweet, that was fun. Essentially, it's a very special sort in place, followed by finding the first value that is missing in the sorted array. And the only reason why we can do better than n log n is because what we're sorting is a list of positive integers. Normally, that's a pretty easy thing to do because you just allocate an array that is the size of the integers, like the maximum integers, and then you just put them in place. But in this case, we're not allowed to allocate any memory, so that made it even more difficult, and we had to deal with a lot of different edge cases of values that aren't even in our set, or the set that we don't care about, like non-positive ones. Values that technically we don't need to worry about because they're larger than the size of the array, and they'll never be the smallest missing value. We had to deal with duplicates. This one kind of dealing with duplicate values. We don't keep swapping the same value over and over again. And then we had to like deal with swapping things behind us that are already evaluated versus swapping things that are in front of us that haven't been evaluated yet. So a lot of different things we had to take into account. And this part seemed like it was pretty simple. I think we wrote this once and got through it, which was just skip over things that we're not thinking about and keep looking until we find the next expected one. And when we finally hit something that, or we hit the end of the array, then we know that that's the missing one. Okay. That was fun. I don't see any chatters right now, so I will call it. Have a good one.